Welcome back to another lecture. Today we are moving on to polynomials. And first, let's talk about what a polynomial is. We have different types of polynomials. First, let's talk about a monomial. You can probably guess from mono that this is an expression with one term. Let's look at some examples, I guess, of that. We have 5x plus 6, 3x squared plus 7, negative 4 minus 4x to the 9th, right? Anything that looks like that. Whereas a polynomial, so by poly, has more than one term. And maybe we'll, well, no, we can keep polynomial here. 2 plus terms. Tell from poly. Some special types of polynomials. We have a binomial. Bi meaning two terms. Some examples of those are going to be like 6x plus 2y, or y minus x. Those are two terms. You can also have trinomials. Tri meaning three terms. So 3x squared plus 2x plus y plus 1. So here's one term, here's another term, here's another term. 6y plus 9 z plus 4x. It's going to be another one because we have three terms. And we can keep going. Those are all polynomials. Okay, so apart from naming conventions, let's talk about, let's review. Let's combine like terms. So we have, let's say, 3x squared plus 3x plus x plus 1 plus 5x. So what we're going to do is we're going to list out all of our separate terms. Those that have exponents are going to be separate. So for example, x squared is going to be separate from x, and then we have our 1s. X squared, we just have one x squared term. X, we have a 3 and a 1 and a 5. And then the one terms, we just have a 1. So altogether, we get 3x squared. Oops, I forgot to simplify this. That's 9. Plus 9x plus 1. And typically, whenever I'm writing polynomials, I like to write them in descending powers. So biggest power on top, biggest exponent on top or in front, and then next one, and then next one. Oops. Okay. So that's kind of review, that's kind of new, but basically it's the same information we've been doing all along. Just know that different powers of a variable are its own term. You can't combine them. Okay, let's look at another example. A lot of these are a whole lot more motivated by examples than what we've done in the past, I think. It's a lot easier to explain with examples. So let's do a squared plus 7b squared minus 4a squared. Again, identify our terms. We have an a squared. Let's throw on a 5a. Why not? We have an a squared term. We have an a term. And yeah, let's throw on a 4. We have, I guess actually let's do this in descending powers. We have an a squared term. We have b squared terms. We have an a term. And we have 1s. A squared, we have 1 minus 4. B squared, we just have 7s. A's, we just have 5s. ones, we just have 4s. So our answer is negative 3a squared plus 7b squared plus 5a plus 4. So it's just combining like terms, just with different exponents. Okay, let's do some more adding, and then we'll do some multiplication, we'll do some subtraction. We're not going to do any division today, or I think even in this course, but we will do multiplication. So let's do negative 5x squared minus 10x plus 2. That's our first polynomial. And our second polynomial we're going to add to that is 3x squared plus 7x minus 4. We do this. We have x squared, we have x's, and we have 1's. We have negative 5 and a 3. We have a negative 10 and a 7. And we have a 2 and a negative 4. Negative 5 and 3 is negative 2. Negative 10 and 7 is negative 3. 2 minus 4 is negative 2. So our final result is negative 2x squared minus 3x minus 2. That's our polynomial. Okay, let's do another one, but this time with subtraction. It's going to work just like you would expect. 15x squared plus 12x plus 20 is our first polynomial. Our second polynomial is going to be 9x squared plus 10x plus 5. Okay, first thing we're going to do is distribute that minus sign. Next thing we're going to do is use the associativity property of addition, which we use back here in this example. I didn't write it out. And we get 15x squared plus 12x plus 20 minus 9x squared minus 10x minus 5. Okay, use the commutativity property. We get 15x squared minus 9x squared plus 12x minus 10x plus 20 minus 5. Let's throw in the associativity property. 15x minus 9x is 6x, 15x squared minus 9x squared is 6x squared. 12x minus 10x is 2x. And then 20 minus 5 is 15. Now let's multiply. Again, it works just like you would think. We're going to first multiply with monomials. 10x times 4x plus y. But we're going to use the distributive property, and we know that that's the same thing as 10x times 4x plus 10x times y. 10x times 4x, we can, I'll go ahead and explicitly do this time. That's 10. We can use the associativity property of multiplication and do 10 times x times 4 times x plus 10 times x times y. Using the commutativity property of multiplication, we can write this as 10 times 4 times x plus 10 times xy. 10 times 4 is 40. I guess we're implicitly using the associativity property there, right? So 10 times 4 is 40. X times x is x squared, and then 10xy. Now let's do binomial multiplication. So maybe we should back up and say monomial multiplication maybe looks like ax times bx plus c. We can use the distributive property and get that's ax times bx plus ax times c. And rearranging, doing the exact same process as what we did back here, we can get that that's abx squared plus acx. Doing this now for binomials, we have, let's do it in general first. A plus B times C plus D. Okay, first thing we're going to do is we're going to do the distributive property, which is going to say that's A plus B times C plus A plus B times D. And then each one of these, we can use the distributive property. That's AC plus BC plus AD plus BD. Okay. And then we can, but we're done, actually. That's how we multiply sums, using the distributive property. One way you can think of this is a method called, there are lots of different ways to do it, but one is a method called FOIL. FOIL stands for, let me write it up here, FOIL. F is first, O is, I think, outer, I is inner, and then L is last. So we're going to do firsts, A times C, which is what we get there. And then the outer ones, A and D, which is that one there. I'm sorry, that's B and D, that one there. And then we have inner, which is B times C. And then last, which is B times D. So maybe I should put that on its own page. Using the FOIL method, A plus B, C plus D. We have A times C plus A times D plus B times C plus B times D. That's FOIL. There are other ways. I'll show you another way. You can think of it as a box, A, B, C, D. Really, it works the same way as like a times table. A times C is AC, B times C is BC, A times D is AD, B times D is BD. So then you just read them off. AC plus BC plus AD plus BD. You'll see they're the exact same terms. Different order, but same terms. Okay, so let's do some examples. 4x plus 5 times 4x plus 2. Using, we'll just, I don't know, we'll use the box method, I guess, for this one. We got 4x plus 5, 4x plus 2, 4x and 4x is 16x squared. 5 and 4x is 20x. 4x and 2 is going to be 8x, and then 5 and 2 is 10. So we get 16x squared plus 20x plus 8x plus 10. We can simplify those two terms and get 16x squared plus 28x plus 10. We have a whole list of these we're going to go through because it's very important. And college algebra is kind of predicated on your ability to do this. So 2 minus x times 4x minus, we'll do 3. I won't draw the arrows this time, but, well, we did box last time, so I will draw the arrows this time. So we get 2 times 4x, which is 8x, and we get 2 times negative 3, which is negative 6. Then we get negative x times 4x, which is negative 4x squared. Then we get negative x times negative 3, which is positive 3x. We can simplify, and I'm going to rewrite it in terms of descending powers. It's negative 4x squared, which is this term. Maybe I'll do it in a different color. This term. And then we got the 8x and 3x giving us 11x. And we have minus 6 for completeness. I'll do that. So there's another one. This was with the box. This was with FOIL. Okay, let's do some more. 3 minus s times 1 minus 2s. This is 3 minus 6s minus s plus 2s squared. Rewriting that, get 2s squared minus 7s plus 3. I'll leave you to verify the details on that for whichever method you want to use. Let's do 7 minus x squared. Now remember, this is not 7 squared minus x squared. It's very, very important that you don't make that error. What it is 7 minus x times 7 minus x. Seven times 7 is 49. 7 times negative x is negative 7x. Negative x times 7, negative 7x. And the negative x times negative x is positive x squared. Rewriting and simplifying, we get x squared minus 14x plus 49. Again, you can fill in the details using your favorite method. You can see if you're going through these methods, the previous one I did, I used FOIL. And this one I used FOIL. That's kind of my go-to method. Okay, let's make it a little more complicated. X plus 3 times, no, actually, in general, we're doing general case first. Let's say we have a plus b, our normal binomial, and then we have c plus d, which was, if we stopped there, that's multiplying binomials, which is what we've been doing. Let's throw in an e. So now we have a binomial times a trinomial. And so working through this, we get, using the distributive property, a plus b times c plus a plus b times d plus a plus b times e. Using the distributive property on each one of these, we get ac plus bc plus ad plus bd plus ae plus be. And that's our most general form. Now we can, of course, simplify this, again, using a FOIL-like method. It's not going to be exactly like FOIL, or the box method. Let's start with the box method, and you'll see we'll get the exact same answer. We'll do a plus b on top, and we'll do c plus d plus e along the side. A times c is ac, b times c is bc, a times d is ad, b times d is bd, a times e is ae, b times e is be. Let's make sure we're getting the same answers here. AC, AC, BC, BC, AD, AD, BD, BD, AE, AE, BE, BE. So, same answer. AC plus BC plus AD plus BD plus AE plus BE. I should definitely note here, don't memorize this. This is just a derivation, so you can see that these methods work. Please don't memorize that formula. Instead, memorize how to use, like, the box method. Another way you can use is something like FOIL, but it's not going to be exactly FOIL. Okay, what we're going to do is a times c, just like we did before with FOIL, and then a times d, like we did before with FOIL, but this time we're going to extend it one more and say a times e. Then we're going to do the same thing with b. We get bc, bd, be. And you can check, we have AC, BC, AC, BC, AD, BD, AD, BD, and we have AE, BE, AE, BE. So it's the same answer, just different way of doing it. Again, my default method whenever I'm multiplying these out is going to be FOIL, or this isn't technically FOIL, but this FOIL-like method. That's how I prefer to do it. So let's actually put some examples here. X plus 3 times x squared minus 5x minus 4. Okay, let's start with the box. X plus 3. Note, it doesn't matter if what you have is which one's on top and which one's on the side, because it's going to come out to the same either way. I guess that's not so much of a box, but that's fine. X times x squared is x cubed, right? Because x to the 1 times x to the 2 is x to the 1 plus 2, which is x cubed. X squared times 3 is 3x squared. X times negative 5x is negative 5x squared. 3 times negative 5x is negative 15x. We have 4 times x is 4x, and then 3 times 4 is 12. So our final answer, x cubed plus 3x squared minus 5x squared minus 15x plus 4x plus 12. We can simplify that to x cubed minus 2x squared minus 11x plus 12. Can I squeeze it in there? Okay, it's using the box method. We'll do x minus 3 times x squared minus 5x minus 4 using the FOIL-like method. So x times x squared is x cubed. X times negative 5x is negative 15x squared. X times negative 4 is negative 4x. So what we just did were those three. Now we're going to do these. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 5x is plus 15x. And then negative 3 times negative 4 is plus 12. Now combining like terms, let's see, we got the x cubed term here. We got the x squared terms here. We got the x terms here, and we got our constant. So we get x cubed minus 18x squared plus 11x plus 12. Okay, so you can take these ideas and continue to generalize them. One thing I noticed that wasn't in Lumen is multiplying trinomials. And that is going to be, it's going to follow the same process. And so I want to show you one. It's going to work just like you think. We'll do the exact same one with the box method and the FOIL method. 2x squared minus 3x plus 6 times 5x squared minus 4x plus 2. Again, this isn't in Lumen, but I think it's instructive because if you're able to do this, that means you have the solid understanding of the material, the concepts. So we're going to do the kind of the exact same thing as what we did before. But for, I said I'd start with box. 2x squared, negative 3x, 6. We have 5x squared, negative 4x, 2. Okay. 5x squared and 2x squared is 10x to the 4th. 5x squared and negative 3x is negative 15x cubed. 5x squared and 6 is 30x squared. Negative 4x and 2x squared is negative 8x cubed. Negative 4x and negative 3x make 12x squared. Negative 4x and 6 make negative 24x. 2 and 2x squared make 4x squared. 2 and negative 3x make negative 6x, and then 2 and 6 make 12. Okay, I'm going to simplify this as we go along, because you can see we can simplify there, we can simplify all those, and we can simplify those, the diagonals. So we get 10x to the 4th. Okay, negative 8 and negative 15 is going to make negative 23 x cubed. Get 4 and 12 make 16. 16 and 30 make 46. And then negative 6 and negative 24 are going to make negative 30. And then 12. Again, if you're able to do this, then you have a solid understanding of the material. Let's do the exact same problem again, but with FOIL. Not FOIL exactly, but the FOIL-like method. Plus 2. I did 2 before, right? Yep. So we're going to start with this. So we get 10x to the 4th minus 8x cubed plus 4x squared. And then we're going to do minus 15x cubed, because now we're doing this one. Minus 15x cubed plus 12x squared minus 6x. And then I'm going to use a red color for this. We're going to do the 6 as well. So plus 30x squared minus 24, I did plus, minus 24x plus 12. Let's add all these together. 10x to the 4th, or we're simplifying all of these, minus 23x cubed plus 4 and 12 make 16 and 30 make 46x squared minus 30x plus 12. Hopefully that's the exact same thing as what we got back here, and it is. Okay, that's going to do it for our lesson on polynomials. So we've covered all of polynomials now, and we're just left with 2 more modules, the factoring module and the graphs module, which I believe will end up being about 3 lectures. So